Okay, so good afternoon all. The screen is visible, my voice is audible.
Yes, ma'am. Yes, ma'am.
Okay, so let's start. So today we are going to start our third unit. So the name of the unit is the data link layer. So as I already told in last unit that we have seen the OSI reference model where 7 layers are present. So in that model, data link layer is there. So the task of the data link layer is to deal with all dealing with the data only. So that is the main task of data link layer that we have seen in the OSI reference model. So in this chapter, we are going to see in detail what is the actual work of the data link layer, how it does the framing, how it deals with the data, how the errors are detected at the receiver side, at the sender side, which are the algorithms. So all that part we are going to see in this chapter, that is unit number 3, data link layer. So let's start the unit. So these are the content of this unit. So data link layer design issues, then error detection and correction, then elementary data link layer protocol and sliding window protocol. So these are the key points that we are going to see. So though the content is too small, there are lots of points are there which will be there in these main points. Okay, so we'll see. So what is mean by the data link layer? So first, data link layer, it is the linking of network to network to send the data by using protocols from one place to the another place. So data link layer, it is one of the layer of the OSI as well as it is combined in the TCP/IP reference model also. And the work is to send the data by using some protocols or the strategy from one place to the another place. So while sending the data, it has to take care whether the data is error free or it is having some error, whether the whole data is continuously sent or not. So all that part come under a data link layer working. Okay. So it is the one of the OSI reference model layer and its task is to connect or to send the data from one place to the another place. So that is the uh, task of the data link layer. Then central idea of the chapter. So this chapter introduces design issues of the data link layer and various methods of error control and detection of a flow control. So in this chapter, we are going to see how the data link layer is actually designed, what are its design issues, how data is being sent, also which are the algorithms used for error detection, correction, error control, flow control, and all. So all this comes under we are going to see under this chapter. Then importance of the chapter. So it deals with the various algorithms for achieving reliable, efficient communication between two adjacent machines which are connected through some link layer. Okay, so as already we have seen that in this chapter we are going to see various algorithms. So these algorithms are useful to achieve the reliable or error-free or efficient communication between the two nodes. So that's why this chapter is important. Then these are the objective and outcomes of a chapter. So first one is the to understand various functions of a data link layer, means what is the actual purpose of the data link layer, what it does in OSI reference model in detail we are going to see. Then second task is to understand and implement error control and detection method. So there are certain algorithms that we are going to study, as well as we are going to implement that algorithms also. Then next is to understand and implement error detection and correction methods, and to understand the concepts of a sliding window protocol. So there are certain protocols as like sliding window, go back in. So these protocols comes under a, a data link layer, uh, or the TCP/IP reference model. So that we are going to cover in this chapter. So let's start. So first point is data link layer design issues. So before going forward, just remember the diagram of the OSI reference model. So we are having the 7 layers in that. So 7 layers which starts from application, presentation, session, transport, then network, data link, and physical. So the sequence for this data link layer is what? First one, for example, it is my physical layer. Then second one is the data link layer, and then third one is suppose network layer. Okay, so this data link layer is middle of physical layer and the network layer, remember it. So if we consider from sender side, it comes after the network layer, and if we consider from the receiver side, it comes after a physical layer. Okay, so this is the data link layer. Now while this while designing any network, so there are some issues that needs to be taken into consideration. So let's see what is that issue. So this data link layer performs number of functions. Okay, for example, it does the framing, or it sends the data error free to the receiver and all. But the main task of this data link layer is to take the data from physical layer and transfer to the network layer. So that is the main task of a data link layer. So while performing this task, data link layer takes the packets from network layer and encapsulates them into the frames for the transmission. Okay, so when or for sending the data from network layer to the physical layer or physical to the network layer, so it takes the packets in the sense information or your data from any layer and encapsulates them into the frames. Okay, so in case of the third chapter, whenever the term data will be come, instead of packets we will talk it as a frames, because these packets are divided into the frames. Okay, or these are converted into the frames. Now what this frame contains, so frame, it is the it contains some data along with its headers and tailors. Okay, so this is the simple format for a single frame. See, packet is what, or data is what. For example, I'm having this data 1011 and 0. This is my data, or this is my packet. When it comes to the data link layer, this packet or data is divided into the frames. Now what is this division contains? It adds some headers to this particular data or the packet. It adds some trailers to this packet, and this whole content is considered as one frame. So in this chapter, whenever data or packet comes, it will be a frame only. And each frame contains header, then payload field and trailer. Now, what is header? Let's see. Suppose sending machine and a receiver machine is there, and packets, these are divided into this one. So header, payload field and trailer. So header will have a address, then payload field, it is having the actual data, and trailer is nothing but where your actual frame is ending, so that will be over trailer. Okay, so we can say that header will be the starting of the frame, then payload field means actual data, and trailer means end of the frame. So each packet is get divided into such format, and this task is done by the data link layer. Remember, okay, so whenever data comes to the data link layer, either from physical layer or from the network layer, so it first get divided into these frames, and this is the frame format. So every data is encapsulated with headers and trailers along with it, and then only it is being sent to the destination. Okay, so this is the task of the data link layer. Now, yes. So these are the main tasks which data link layer actually does. So first one is the providing service to the network layer. Then second is the framing. Then third one is the error control, and fifth one is the flow control. So these are the four tasks, and depending upon these four tasks, your whole chapter is there. Okay, we'll see one by one. So first task, providing service to the network layer. Okay, so providing service to the network layer, it means that when the data comes from a physical layer, then that data will be sent to the network layer, and it is done by the data link layer. Okay, so the function of a data link layer is to provide service to the network layer, and to perform this task, it has to take the data from the physical layer. Okay, so while transferring the data from a source machine to the destination machine, we are saying that the communication is happening end to end communication. What is the meaning of end to end communication? For example, this is my network layer, and this is also my network layer. So what we say that end to end communication means this one, layer to layer communication, means directly data is sent from network layer of sender machine to the network layer of receiver machine. So this is end-to-end machine, end-to-end communication, and which is called as a virtual path data, or data follows the virtual path if the communication is end-to-end. But in reality, actually data travels through different layers. So that we have seen, means though from network layer it is going to the network layer of receiver, it has to go to first data link, then physical medium, again to the physical medium, data link layer, and the network layer. So it is nothing but the actual data path. ओके, सो डायरेक्टली कोणताच डेटा नेटवर्क टू नेटवर्क कम्युनिकेट होत नाही. सो त्याला लेअर वाईज स्ट्रक्चर थ्रू हे व्हावं लागतं, ट्रॅव्हल व्हावं लागतं. सो दॅट इज नथिंग बट द ऍक्च्युअल पाथ ऑफ द डेटा टू बी सेव्ह. नाव वाय when this services are provided by the data link layer to the network layer, these services are of three types. Okay, so first is what, unacknowledged connectionless service, second is acknowledged connectionless service, and third one is the acknowledged connection oriented service. Now we'll see what is mean by all these three. These are the three services which are provided by the data link layer to the network layer, आणि ज्यावेळेस या सर्व्हिसेस प्रोव्हाइड होतात त्यावेळेस that can be of these three types. Okay, now what is unacknowledged connectionless service? So in this type of the service, source machine sends independent frames to the destination machine without having the destination machine acknowledge them. Okay, now first, what is mean by the acknowledgement? What is acknowledgement? Any idea? Yes, acknowledgement means what? Yes, any idea? Acknowledgement means what? हा, एक्नॉलेजमेंट म्हणजे काय? ओके, लेट इट बी. व्हॉट्सअप वरती आपण एखादा मेसेज सेंड केला तुम्ही तुमच्या फ्रेंडला, त्या फ्रेंडनं वाचलाय का नाही वाचला हे कसं कळतं तुम्हाला? आता हे तर आलंच पाहिजे. या,
ब्लू
हे आन्सर्स पटापटा येतात. हा, कसं? ब्ल्यू लाईन्स आपल्याला भेटतात.
ब्लू
येस, ब्ल्यू लाईन्स येतात तिथे किंवा ब्ल्यू मार्क्स येतात. त्याच्यावरून आपल्याला काय कळतंय की या that particular person has read that message. Similarly, ज्यावेळेस सेंडर आणि रिसिव्हर कम्युनिकेट होत असतात त्यावेळेस काय होतं, सेंडरने जो मेसेज सेंड केलेला आहे, वेदर रिसिव्हर हॅज रिसिव्ड दॅट मेसेज ऑर नॉट, हे सेंडरला कसं कळणार? वेन रिसिव्हर विल सेंड एनी एक्नॉलेजमेंट टू द सेंडर. ठीक आहे, सो दॅट इज नथिंग बट द एक्नॉलेजमेंट. सेंडर आणि रिसिव्हर मध्ये कम्युनिकेशन होत असताना सेंडरनं मेसेज सेंड केलाय, सेंडरला समजलं पाहिजे की रिसिव्हरला मिळालंय का नाही. याच्यासाठी रिसिव्हरनं एक्नॉलेजमेंट सेंड करणं गरजेचं असतं. कशीही असू दे एक्नॉलेजमेंट, मग ते कोणत्याही फॉर्मॅटमध्ये असेल, पॉझिटिव्ह, निगेटिव्ह, एखादा नंबर असेल, एखादा मेसेज असेल, व्हॉट एव्हर, फक्त एक्नॉलेजमेंट आली पाहिजे, जेणेकरून sender confirm will that yes, my message is reached to the destination and it will send the next message. That is nothing but the acknowledge. But in case of this type of services, unacknowledgement means what? Sender sends the message but receiver is not sending any acknowledgement, and in this case, that is connectionless, there is no fixed path, or the frames are sent independently to the destination. So that is nothing but the unacknowledgement connectionless service. Okay, so no logical connection is established or no acknowledgement is sent, and such type of service, such type of communication or the service is called as a unacknowledgement connectionless service. Now, in this case, suppose in between any frame is getting lost due to noise or some external effects on the wire or any condition. If such thing is happen, still sender is not able to know anything about the frame as it is an unacknowledged service. जरी इन बिटवीन एखादी फ्रेम लॉस्ट झाली तरी सुद्धा सेंडरला कळणार नाही की वेदर माझा मेसेज गेलेला आहे और नाही, कारण की इट इज अन अनएक्नॉलेज्ड सर्व्हिस. ठीक आहे, सो दॅट इज द फर्स्ट टाइप ऑफ द सर्व्हिस. देन next, acknowledged connectionless service. Now you can tell, acknowledged connectionless service. So connectionless means what? There is no logical connection is established between sender and receiver. Frames are transmitted freely or without any direction. That is connectionless. And acknowledgement means what? That sender gets an acknowledgement from the receiver. Okay, so unless and until the acknowledgement of first frame is received by the or received from the receiver, sender is not allowed to send the second frame. That is nothing but the acknowledged connectionless service. जोपर्यंत पहिल्या फ्रेमचा acknowledgement receiver सेंड करत नाही तोपर्यंत सेंडरला दुसरी फ्रेम सेंड करायचे अलाउड नसतं. दॅट इज नथिंग बट द एक्नॉलेज्ड. आणि कनेक्शनलेस म्हणजे काय की फिक्स्ड पाथ नाही, फ्रेम तुमच्या फ्रीली ट्रॅव्हल होऊ शकतात, वायरलेस कम्युनिकेशन. Okay, so that is the second type of the service which is provided by the DLL to the network layer. And the third one, acknowledged connection oriented service. So in this acknowledged, again the same like this, that is acknowledgement should be sent by the receiver, and there is a fixed path through which only that your frame should travel. So that is nothing but the connection oriented. Means for example, by using coaxial cable. Okay, so by using this cable, by using some fixed topology, only that by using some rules only your frames can be sent. So that is nothing but the acknowledged connection oriented service. So these are the three services which are provided by the data link layer to the network layer. Clear?
Yes, ma'am, clear.
Okay, so this is the first task done by the data link layer. Now the second task, and it is the most important task of a data link layer. So second task is the framing. Okay, and this task is totally related with your data. Okay, so what is mean by the framing? So to provide the service to the network layer, data link layer has to use the services provided by the physical layer, because from the physical layer itself it gets the data. So it has to use the services which are provided by the physical layer, and physical layer accepts what the physical layer is having. It accepts, or it is having the data, okay, or we can say the raw data in the formats of the 1 and 0. Okay, so physical layer accepts this data and delivers to the destination with data link layer. So this service is used by the data link layer of physical layer. Okay, so when this data is along with the data link layer, okay, so at that time it may possible that that data or that bit stream may have some error. It can be possible. So what the type of error may be possible? That some data is lost, means there is no actual data, so size can be varied, or the bit can be changed. Instead of 1 here 0 is being seen. So any type of error can be occurred between this transmission. Okay, so when the data comes to the data link layer has to take care about all these things. Okay, so it has to detect this error if it is there, and if the error is there it has to correct it also. Okay, for which it follows some algorithms. That algorithm we are going to see. Okay, so this data link layer takes the packets from the network layer and encapsulates them into the frames. Now, if the frame size becomes too large, then the packet may be divided into small sized frames. So that already I have told in first point. So task of breaking data into the frame is quite difficult. And for this purpose, different techniques are used. Okay. Now, what is this sentence? Please listen. So task of breaking data into the frames means what? I'm having this frame 1011, again 0, again 1 1. This is my data, or this is my packet, and I have to uh, divide this frame, sorry, this packet into the frame, means I have to add some headers and trailers to this data. Okay, and dividation of this data or this packet into the format of the frame is difficult, and for this purpose some techniques or different techniques are used by data link layer. Now we'll see what are those techniques. So framing is nothing but, or it is of two types. Okay, so first one is the fixed size framing, and second one is the variable sized framing. Fixed sized framing means what? Here the size of the frame is fixed, and the frame length acts as a delimiter to the frame. Now what is the use of the delimiter? See here, this is my data 10111011. Now suppose rule is what? Your data should be of 4 bit only. हा डेटा फक्त एवढाच पाहिजे. मीन्स व्हॉट? माझा एक फ्रेम काय असेल? 1011. त्याला हेडर असेल, टेल असेल, आणि नेक्स्ट काय असेल माझी? 011. आणि ह्याला काहीतरी हेडर असेल, ह्याला काहीतरी टेल असेल. बट हे झालं सेंडर साईडला. When it reaches to the destination, how destination will know that this is one frame and this is second frame? Okay, means there must be some separator between these two frames. काहीतरी सेपरेटर पाहिजे ना ह्या दोन डेटाच्या मध्ये, जेणेकरून ही एक फ्रेम आहे आणि ही एक फ्रेम आहे हे समजेल. Then this separator or delimiters are added itself by the data link layer, and for which different methods are used. Okay, now in case of the fixed sized framing, as the size of the frame is fixed, there this a particular length or the size of the frame itself acts as a delimiter. Means what? Suppose 4 bits of data hai, so only that much frame will be same. So there is no need of extra delimiter. For example, ATM cells that we have seen, ATM reference model मध्ये बघितलेले. What is the size of the ATM cell? Sorry, what is the size of the ATM cell? Yesterday only we have seen this. ATM reference model मध्ये हे बघितलेलं आहे. What is the size? It is of 53, na? Yes or no?
Yes, ma'am.
Then it is of 53 bytes. Measure 53 bytes. It is fixed. ATM cell is of 53 bytes. So obviously after 53, next bit or next frame will be considered as a new frame. So in such cases where the size of the frame is fixed, there is no need of any separator or any technique for the data link layer. But if the frame is of variable size, means the frame ची size काय है vary होते, then there is a need of a separator. Means there should be some mechanism to keep the mark of end of the frame and the beginning of the next frame. Means कळलं पाहिजे की इथं फर्स्ट फ्रेम संपते आणि इथून पुढची नेक्स्ट फ्रेम चालू होते, because the size of the frame is varied. Okay, so for that purpose these methods are used in a framing. First one is the character count, second one is the byte stuffing, and third one is the character stuffing. Remember, हे सगळं आपण काय बघतोय? What is this? It is the one task of a data link layer, framing. ठीक आहे. आणि फ्रेमिंग म्हणजे काय? इन शॉर्ट लक्षात ठेवा, फ्रेमिंग इज nothing but adding something at the start of the data and end of the data. That is nothing but the one type of the frame. And what is this something? So this something comes if the frame is of variable size. जर फ्रेमची साईज जर व्हॅरी होत असेल तरच त्याच्या स्टार्टला आणि एंडला काहीतरी डेलिमिनेटर ऍड करायची गरज असते, अदरवाइज नो. If the frame size is fixed, then there is no need of any of this method. Okay, so to add something at the start and end of the frame, we need some methods, and these are the three methods. Okay, now we will see one by one. First one is the character count, then second one byte stuffing, and third one is the character stuffing. So we'll see one by one. First one is the character count. So this is the first method that we are going to see. So this method uses the field in header to specify the number of characters in the frame. Okay, now what is the meaning of it? See the diagram over here. So 5, 1, 2, 3, 4, up to this one frame is there. Then 5, 6, 7, 8, 9, up to this the second frame is there. Then here third frame is there, and here next frame is there, and from here the last frame. Now from this what you understood, that this is my header 5, and what the character count method tells, that it uses the field in the header to specify the number of characters in the frame. It means that if I have entered 5 over here, then there will be the data including 5, total fields will be 5. ठीक आहे. माझा डेटा काय असणार आहे? 1, 2, 3, 4 and 5. 5 fields डेटा असेल. So what this 5 tells, that after this 5 minus 5, 4 fields will be there of data. Okay, so that is my character count. Similarly, again 5 is there, means after this 4 field data will be there. 3, then 1 and 2, this one. then 4, then 3 field data will be there. So this is my character count first field. आणि ह्याच्यावरून काय कळतंय की एवढा डेटा माझा पुढे असणार आहे इन्क्लुडिंग हेडर. मीन्स वॉट, तर सपोज मी 5 एंटर केले, मग मला डेटा फील्ड काढायचे असतील तर किती असणार आहेत? 5 मायनस 1, दॅट इज हेडर मायनस 1. Okay, so whatever header count will user will give, minus 1 data field are allowed in that particular frame. Okay, so this is nothing but the character count. Okay, now when the data link layer at the destination side sees this character count, it knows how many characters follow and hence where the end of the frame is. So याच्यावरून काय कळते? 5th आहे, म्हणजे destination will understood that the header field is 5, means first frame will be 5 minus 1. So here the first frame ends, and from this 5th the next frame is started. So you can see here every frame is of different size. So this is the variable sized framing, and for this purpose we need some methods to separate these fields. Okay, suppose I have not told that suppose हे headers नाहीयेत, हे असं character count नाहीये, असं जर नसतं माहिती, then how we can understood that this is first frame, this is second, this is third? There is no any way to recognize this. So to recognize the end of the first frame and start of the second frame, these headers are used as a character count. Okay, so but in this character count method, there are some disadvantages that the count can be garbled by the transmission error. Means when the data or this frame or this whole data is sent by sender to the receiver, and at the receiver side, it may possible that this character count get changed or some error will occur. असं होऊ शकतं. So if such case occurs that this count is changed, then it is not possible to recognize which is the end of the frame and which is the start of the frame. So see here, same example I have taken. So first is what? 5. So 1, 2, 3, 4. So here my first frame is get over. Frame number 1, 5 character as it is. But now for the second, what is my header? It is 5. But at the receiver side, it has become as a 7. So this frame at the center side is ending at this character, but as it becomes 7 over here, it will end 1, 2, 3, 4, 5 and 6 over here, correct? And according to this strategy, now 2 will be the next character count, correct? समजते? काय झालं बघा, 5th as it is आली फॉर एक्झाम्पल. नाव सेकंड फ्रेमचा हेडर काय आहे? सेंडर साइडला काय आहे? 5 आहे. पण रिसिव्हर साइडला ज्यावेळेस फ्रेम जाते त्यावेळेस 5 च्या ऐवजी तो 7 झाला. फॉर एक्झाम्पल 7 झाला म्हणजे काय झालं? 7 बघितलं रिसिव्हरनं, मग रिसिव्हर काय म्हणणार? इथून पुढचे 6 फील्ड्स काय असणार आहेत? डेटा फील्ड असणार आहेत. मग 1, 2, 3, 4, 5 and 6 हे झाले माझे डेटा फील्ड. सो इथं सेकंड फ्रेम एंड झाली असं रिसिव्हर अज्युम करेल, आणि दिस 2 विल बी द नेक्स्ट फ्रेम. ठीक आहे. सो अगेन 2 मीन्स व्हॉट? हिअर द नेक्स्ट फ्रेम विल गेट एंड. म्हणजे टोटल फ्रेम स्ट्रक्चर चेंज होईल. कशामुळं? ह्या एका कॅरेक्टर काउंटमुळे. So that is the major drawback of the character count method. I hope it is getting clear.
Clear, ma'am.
Is it clear, everyone? Any doubt? Character count method, we have to implement all these methods. Remember, त्यामुळे आताच विचारा प्रोग्राम करायचे त्याच्यावरचे. Any doubt? येस, एनी डाऊट? नो. सगळेजण जागे आहेत ना? का हेडफोन घालून झोपला बिपलाय?
नाही मॅम, येस, जागेत.
No, ma'am.
ओके, गुड. सो कॅरेक्टर काउंट समजलं मेथड?
Yes, ma'am.
ओके.
येस मॅम, समजलं.
Okay, okay, good. So next, the second method or second type is the byte stuffing. Okay, byte stuffing. It is also called as a character stuffing, or it is also called as a flag bytes with byte stuffing. Okay, flag bytes with byte stuffing or character stuffing. It can be anything. So in this method, each frame starts and end with special bytes, or we can say any special ASCII character. Okay, each frame starts and end with special bytes or the ASCII character. Now suppose my frame is this, or my message is this one. So in case of the byte stuffing, for this message there must be some start and end, and this start and end are nothing but some characters. That is nothing but the byte stuffing. So in earlier days, this starting and ending characters were different. म्हणजे स्टार्ट साठी एक वेगळा यूज केला जात होता आणि एंड साठी वेगळा यूज केला जात होता. बट nowadays these all are considered as a flag only. You can see here flag. Okay, so this is our general structure of the frame that we have discussed earlier up to the trailer. So header, payload field and trailer, this is the frame, and flags are added at the start and end of the frame. Okay, so this is nothing but the byte stuffing, adding some characters or ASCII values at the start and end of the frame is called as a byte stuffing. Now what is this character? So as I told you, it can be anything. For example, some are using this as a escape character, ESC, as a flag one, or we are going to use to implement this concept, we are going to use DLE-STX and DLE-ETX as a start and end. Okay, so DLE-STX will be the start of flag and DLE-ETX will be the end flag. So DLE-STX means what? It is nothing but the DLE start, start of the text, and ETX means end of the text. Okay, so DLE, data link escape, start of the text, and data link escape, end of the text. So these two special flags we are going to use as a separator in case of the byte stuffing. Okay, so this method overcomes the drawbacks of the character count method. How? Can anybody tell? By using DLE, STX and ETX, the drawback of this character count method is get over. आता ह्याचा ड्रॉबॅक काय आहे? जर रिसिव्हर साईडला कॅरेक्टर काउंटच कळला नाही एक्झॅक्ट, तर काय होतंय की फ्रेम व्हॅरी होतात. दिस इज द ड्रॉबॅक. सो हाऊ इट इज ओव्हरकम ओव्हर हिअर? How receiver will understood that yes, this is the exact end of the frame, and from here the next frame is started. Any idea? No. Okay, how receiver will understood? So it is easy na, because already we are providing these two characters. Okay, so though receiver means there is some mismatch between the sender and the receiver's data, so receiver has to only check these characters. Okay, so DLE, STX and ETX. So if they are present, means middle data is the information. So that is only it has to check. So it is easy to understood or to recognize the end of the frame and the start of the next frame. Though it is overcoming the drawbacks of the character count method, it is having its own drawbacks. Now, what is this drawback? If, however, binary data is being transmitted, then there exists a possibility of characters DLE-STX and DLE-ATX in the data. Now, what is the meaning of this is that what we are saying that this is the structure and we are considering here as a DLE, STX and DLE, ETX. हा आपला इथला फ्लॅग आहे आणि इथला आहे तो ETX आहे. But suppose in data itself contains DLE, STX and DLE, ETX data. डेटा मध्येच हाच डेटा आहे आला तर काय करायचं? आर यू अंडरस्टँड? ठीक आहे. व्हॉट इज द मिनिंग ऑफ दिस सेंटेन्स? आपण काय यूज करतोय? DLE, STX आणि DLE, ATX हे कॅरेक्टर्स ऍज अ सेपरेटर म्हणून यूज करतोय. ठीक आहे. बट व्हॉट इफ डेटा इटसेल्फ कंटेन्स दिस कॅरेक्टर, डेटा इटसेल्फ कंटेन्स दिस फ्लॅग, देन हाऊ टू रिकॉग्नाइज? जर डेटामध्येच हे फ्लॅग आला तर काय करायचं? So if such cases occurs, then to solve such problem, senders data link inserts an ASCII DLE character just before the DLE character in the data. Okay, so जर असं झालं तर काय करतो? तर सेंडर काय करतो? तर एक ASCII DLE character एंटर करतो. How? See here. So what I told you, at the sender side, data itself is DLE hello. हा डेटा सेंड होतो. Now our flag is what? DLE, STX, DLE, ETX. These flags are there. So if we enter the data without using the any special character, so receiver will know that, receiver will think that this DLE is nothing but the start or end of the frame. Means it will consider this DLE as a flag only, but this is our data, not a flag. So to separate this data from flag, what is done is that one more DLE is inserted before this data. Okay, so you can see now what will be the frame format? DLE, STX, again DLE, and then your actual data, and then DLE, ETX. Okay, so this is the special ASCII character which is inserted by the sender itself to separate this DLE data from DLE flag. Now, when the receiver receives this DLE, receives this data, so it will first find this DLE STX. So it will recognize that yes, it is the start. Again, it will find the DLE. So first DLE will be removed by the receiver, and it will consider the next as a data and then end of the frame. ठीक है, समझलं? What is this? Yes or no?
Yes, ma'am.
समझलं? What is this DLE? Why this extra DLE is added? Because see, characters आपण separators काय use करतोय? DLE, STX and ETX. But problem will occur if data itself contains this character. So to separate out this, if data is equals to the flag, then one more DLE is inserted before the data. So when the receiver finds DLE STX, it will understood that it is the start of the frame. But after this DLE STX, it again finds the DLE, then automatically receiver will remove this, and the next field or next characters it will consider as a data. Okay, so that is the solution for the problem of this character stuffing method. Okay, now so though the character stuffing is easy, or it is overcoming the problem of the character count method, there is one more problem in transmitting the data, is that it just allows a successful transmission of 8-bit characters only, up to 8-bit character. So if the size of the data is too large, in that case this method is not feasible. Okay, means one frame means there is restriction that one frame must be of 8 characters only. After that, it will not work. So that these are the drawbacks of this particular character stuffing method. Okay, and the third one is the bit stuffing method. So remember the difference between bit and byte stuffing. This was the byte stuffing where we are inserting the characters as a separator, and this is the bit stuff where we are inserting some bit pattern as a separator. So in case of the bit stuffing, each frame begins and end with a special bit pattern. Okay, so each frame each frame begins and end with a special bit pattern. So what is this bit pattern is this one: 0, then 6 times 1 and 0. It is fixed. Okay, so remember, so this is the frame format, this is the flag. So it is asked many times for the MCQ, remember. So what is the bit pattern? 0, then 6 times 1 and 0. So what will be the data now? So this is my data. इथं काहीतरी माझा डेटा असेल आणि याच्या स्टार्टला हा पॅटर्न असेल आणि याच्या एंडला पण हाच पॅटर्न असेल. So this will be my one frame. Okay, so this is the bit stuffing pattern: 0, 6 times 1 and 0. Now again, what will be the problem over here is again the same as a character stuffing, that what if the data itself contains this flag? It can be a data. Now we can't resist that it should not be a data because it is considered as a flag or it is considered as a separator. No, data itself contains the flag. Okay, so it can be possible that data मध्येच हा flag occur झालेला असेल. So to avoid the problem of the bit stuffing, what sender does is that if data contains such type of pattern, then after five consecutive one ze- five consecutive ones, 1 0 is automatically stuffed. Consecutive means continuous or सलग. इफ असा जर पॅटर्न अवॉइड करायचा असेल तर काय करतो सेंडर, काय करतो, डेटामध्ये जर एक साथ 5 एक सापडले तर 6वं फील्ड हे ऑटोमॅटिकली 0 फील्ड असलं पाहिजे किंवा तो स्टफ करतो. ओके, हाऊ, सी हियर. So this technique is called as a bit stuffing. Now see, this is my original data: 0 1 1 0, then some ones are there, then 0, then 1 1 1. This is my original data. So if you see that it may possible that somewhere this same flag pattern may get occur. It can be possible or not. होऊ पण शकतो आणि नाही पण. But to avoid the consequences, what strategy followed is that whenever in the data 5 consecutive ones are there, 6th field must be 0. So you can see 0, then 1 1 0 is same. Then after 1 2 3 4 and 5, 1 2 3 4 and 5, this 0 is added here. Okay, then again the pattern will goes on continuously, but again after 5 consecutive ones, again 0 is get added. Similarly, it follows the same pattern for all the data. Now when it reaches to the receiver side, at the receiver side, so receiver will do again, it will check that check the data, and if receiver finds again 5 consecutive one, then next field it automatically destuffs. Destuffs means remove करतो to get an original data. ओके, सो यू कॅन सी हिअर रिसिव्हर साईडला काय केले बघा, येतं ना, हे 5 1 झाल्यानंतरचा 0 आहे तो काय केला, रिमूव्ह केला. अगेन आफ्टर दिस 5 दिस 0 इज गेटिंग रिमूव्ड. याला काय म्हणतात, डिस्टफिंग किंवा काढून टाकणे. जेणेकरून रिसिव्हरला त्याचा ओरिजिनल डेटा रिसिव्ह होईल. Am I clear? ओके. सेंडर काय करतोय, 5 कॉन्झिक्युटिव्ह वन्स झाले, कॉन्झिक्युटिव्ह मीन्स कंटिन्युअस 1 आले की 6th फील्ड हे 0 एंटर करतो. मग डेटा मधलं 6th फील्ड काही असेल, no matter. If 5 consecutive ones are there in a data, 6th field must be 0. That rule sender follows. And what the receiver follows? If 5 consecutive ones are there, 6th field should be removed or destuffed. So obviously 6th field will be 0. So if it get destuffed, the receiver will get the original data. Okay, so stuffing of 0 is done by the sender and destuffing of the 0 is done by the receiver. समजते का? Yes or no? Any answer? समजले थर्ड पॅटर्न ना, थर्ड मेथड?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
नक्की समजले का? हे इम्प्लिमेंट करायचंय तुम्हाला, बिकॉज this is very easy and it is our one experiment to implement character byte character count, byte stuffing and the bit stuffing. So at the time of external, these programs may come. Okay, so remember character count means what? First we have to take the count from the user and -1 data should be there. Then in byte stuffing, some characters are included at the start and end of the your particular frame, and in case of the bit stuffing, this pattern should be there at the start and the end, and प्रत्येकाचे drawbacks and how that drawbacks are overcome. ठीक है, so these are the 3 methods. So framing is the main task which is done by the data link layer, or which is provided by the data link layer to the network layer. ठीक है, so here first task of the data link layer is over. Now we will see one technique of this, that is character count. We will implement over. I will show you the program for this. I will do the program togetherly. You can tell me. माझी screen दिसते? This
Yes,
screen
ma'am.
is visible. Program की screen.
Yes, ma'am.
Turbo C की screen दिसते का?
Yes, ma'am. Yes, yes.
Okay, fine. Okay, so we'll do it. So हा पॅटर्न आपल्याला इम्प्लिमेंट करायचा आहे. ठीक आहे, सो नाव यू कॅन टेल मी द लॉजिक. व्हॉट शुड वी डू फर्स्ट? काय करावं लागेल? या एनीबडी कॅन टेल. व्हॉट शुड आय डू? टेल मी. काय करायचं आपल्याला? एक काउंट घ्यायचा, ठीक आहे, किंवा एक नंबर घ्यायचा आणि त्या नंबर, जो नंबर युजर एंटर करेल त्या नंबरच्या -1 फील्ड डेटा युजर कडून घ्यायचा आणि तो डिस्प्ले करायचा. फिनिश. एवढंच टास्क करायचं. सो व्हॉट शुड आय डू?
लूप यूज करावं लागेल ना? लूप यूज करावं लागेल ना?
लूप यूज करायला. करेक्ट. हा, ओके. सो टू स्टोर द frame or to store the data, we may need some arrays, and to access that data or to display that data, we'll use a for loop. Correct. अजून?
मॅडम ते टीसीडी स्क्रीन मॅक्झिमाइज करेल.
ओके, दिसते का?
हा, दिसते.
Okay, fine. So what we will do, we'll first take input from the user. Okay, step by step we'll go. So I'll write here printf. First we'll take the header size. Okay, header size means first जो आपल्याला count पाहिजे तो. So first I'll take some values over here. integer h will be the header, for example. Okay, so I'll scan it. ठीक आहे, तो काय झाला, हेडर दिला, फॉर एक्झाम्पल 5 दिला हेडर, तो स्कॅन करून घेतला मी. नाव आता नेक्स्ट काय आहे, आपल्याला डेटा एंटर करून घ्यायचा आहे युजर कडून. ठीक आहे, सो आय राईट द सेंटेन्स printf प्लीज एंटर द डेटा. ठीक आहे, सो डेटा एंटर करायचा आहे. बट हा डेटा एंटर किती झाला पाहिजे मला, डेटा किती, या करेक्ट. सो जेवढी हेडरची साईज आहे त्याच्या -1 माझा डेटा असला पाहिजे. ठीक आहे, सो व्हॉट आय विल डू फर्स्ट, I'll take some value, for example d. First I'll declare here d. Okay, so it should be equal to h minus 1. Okay, so again we need to take some arrays over here. For example, print, take as a 60 size and data 60. Will require I also. Okay. So dh print data. So please enter the data and data should be h minus 1. So आता डेटा एंटर करून काय कसा घेणार मी, by using for loop. For I is equals to 0, I is less than d and I plus plus. So just I'll scan it, scanf percentage d comma and data of I. Am I correct? बरोबर आहे का, त्याने काय होईल, माझा डेटा एंटर करून मी स्टोर केला अरे मध्ये. बरोबर आहे, ठीक आहे. आता बघा काय काय झालं, हेडरची साईज घेतली, डेटा एंटर करून घेतला. आता फक्त काय राहिलेलं आहे माझं, तर मला फ्रेम डिस्प्ले करायची. पण फ्रेम डिस्प्ले करताना कशी असली पाहिजे, फर्स्ट फील्ड शुड बी हेडर. याच्यासारखी आता जे आपला आहे तो फर्स्ट फील्ड काय माझा हेडर आहे 5, तो युजरने एंटर केलेला आहे तो, आणि त्याच्यानंतर माझा काय आहे डेटा असणार आहे. सो सेम फॉर्मॅट शुड बी देअर. ओके, so for that what should be done, so what I will do, I'll first write only here as one statement. I'll write printf transmitted frame will be. Now tell me कशी जाणार फ्रेम, कशी डिस्प्ले करणार मी, लक्षात येते. फ्रेमचा फर्स्ट फील्ड काय असणार आहे, माझे हेडरचे जो एंटर केलेला आहे तो, आणि नेक्स्ट काय असणार आहे, डेटा असणार आहे. सो हाऊ शुड आय एंटर, या एनी आयडिया. फ्रेम कशामध्ये स्टोर करणार आहे आपण, या अरे मध्ये. फ्रेम will be stored in the frame array. So how it will get stored, array starts from 0. Yeah, so माझा 0th फील्ड काय असणार आहे, माझा हेडरचे जे साईज युजरने एंटर केलेले आहे तो असेल. सो व्हॉट आय विल राईट हिअर, look whether you understood, frame of 0 means first field of frame, it must be header. जे काही युजर हेडर एंटर करेल तो माझा फ्रेमचा फर्स्ट फील्ड असणार आहे कंपल्सरी. Am I correct? ट्रान्समिटेड फ्रेम मध्ये. नाव फर्स्ट फील्ड तर संपला, आता काय करायचंय मला, फक्त पुढचे फील्ड जे युजर एंटर करणार आहे तेवढेच घ्यायचे. सो अगेन आय मे रिक्वायर फॉर लूप, राईट, बट नाव माय फॉर लूप विल स्टार्ट फ्रॉम
1.
right, it starts from 1 because 0 ऑलरेडी आपण डिफाईन केलाय. 0 फील्ड माझा हेडर बाय डिफॉल्ट असणार आहे, आणि जो युजर डेटा एंटर करेल दॅट शुड स्टार्ट फ्रॉम 1. ओके, सो I is equals to 1, then I should less than are equals to header and I plus plus. Okay. For this, I have to enter the frame. So what will be my frame? Frame of I is equals to data of I. Now tell me whether this statement will execute. This one. Frame of I is equals to data of I. Execute होईल. Yes or no? What will be the value of this I and this I? Okay, let it be. आपण आधी output check करू, then we'll see whether it will execute or not. Okay. So a general concept झाला की my frame will start from first and the next data will get stored to that location. So this will be the execution. Now I'll just display the things over here. For I is equals to 0, I is less than h, I plus plus. Again, printf percentage d, comma, frame of I. Okay. Okay. And just display one separator to remove the print. So for loop is over, this loop is over and gets ch. Done. Okay, so this is the simple program. So let's see the output. Error. Okay, so okay, let me clear the screen first. Enter the header size. Suppose I have entered it as a 4. So three field data should be there for 4 minus 1. So check it whether it is getting entered or not. 1, then 2, then 3. Correct. ठीक आहे. सो इथपर्यंत आपल्या आलेलं आहे बरोबर. बट ट्रान्समिटेड फ्रेम विल बी काय ते बघा. फर्स्ट field is correct, 4 is there, then 1 2 3 should be the data, but it comes as a 2 3 0. 0 is a garbage value, it is not taking the proper way. Okay, so what is wrong here is that it get conflict between these two I. Okay, ह्याचं meaning काय आणि याचं meaning काय. So for that purpose we'll take one more character as a J over here, and what I'll do, I'll first assign it as a 0, and frame of I should be the data of J, and again I'll increase it J plus plus. Okay, so let's check whether it comes or not. Again, suppose 5, 1 2 3 and 4. Yeah, correct. Output समजलं? What we have done? Yes or no? Take it. काय केलेलं आहे? Simple. It is very simple program. बघा किती लाईनचा प्रोग्राम आहे? Hardly 20 line program is there. What we have done? First header size घेतली user कडून, त्याच्यानंतर डेटा एंटर करून घेतला user कडून. तो डेटा किती असला पाहिजे? Header minus 1. And for that we have stored the data in a data array, and then we have just displayed the things. Okay, so frame, while displaying the frame, its first field must be the header. So that's why I have initialized a frame of 0 is equals to header, and again just I have displayed the frame. Clear? समजला program? Yes or no? हॅव यू अंडरस्टूड?
मॅम समजलंय.
सगळ्यांना समजलं सगळ्यांना? एनी डाऊट इन दिस प्रोग्राम? येस और नो? येस और नो सुद्धा म्हणत नाही लोक तुम्ही. हा,
नो. येस मॅम, येस. समजलं.
नो डाऊट समजलं. ओके फाईन. ठीक आहे. सो दिस इज फर्स्ट मेथड. आता now your task is what you have to try these two methods. Okay, byte stuffing and bit stuffing. हे दोन प्रोग्राम्स करायचे आहेत. नेक्स्ट लेक्चर I'll ask randomly anyone, you have to show your program by sharing your screen. Okay, now I'll tell you what should be the output for the byte stuffing. Okay, byte stuffing ला output काय असलं पाहिजे? Suppose I have entered some value. So you can take 10 or any data 1 2 3 4, not specific that you have to take the characters, not required. You can take any data. Only thing is that you have to display that data along with the DLE STX, then data and DLE ETX. So सेम फॉर्मॅट मध्ये मला डेटा पाहिजे. ओके, आउटपुट पाहिजे. नो नीड टू इम्प्लिमेंट दिस ऑल कॉम्प्लिकेटेड थिंग्स. जर डीएलई डेटामध्ये आलं तर परत डीएलई स्टफ केलं पाहिजे. हे नाही केलं तरी चालेल, केलं गुड. ओके, आलं तर करा, नसेल तर राहू द्या. बट बेसिकली व्हॉट यू हॅव टू डू, टेक सम डेटा फ्रॉम द युजर फर्स्ट, देन at the start add DLE STX and at the end add DLE STX and display the string. एवढंच करायचं in case of the byte stuffing. And in case of the bit stuffing, what you have to do, you have to take the data from the user, check 5 consecutive 1, and if 5 consecutive 1s are there, 0 must be inserted after these 5 consecutive 1 and data display झाला पाहिजे. So that will be the task for the bit stuffing. रिसिव्हर साइडला अनस्टफ करून डेटा डिस्प्ले करायचं रिक्वायर नाही. फक्त स्टफ झाला मोर दॅन सफिशियंट फॉर मी आता. ठीक आहे. बिट स्टफिंग मध्ये काय करायचं आहे, यू हॅव टू चेक 5 consecutive 1s. 5 consecutive 1s आहेत का बघायचे डेटामध्ये, आणि असतील तर 6th फील्ड हा 0 एंटर करायचा, आणि जर नसेल तर काय करणार, ऍज इट इज डेटा डिस्प्ले करायचा. ओके, आता हे कसं करणार, हे 5 consecutive 1s आहेत का नाही चेक कसं करणार, एनी आयडिया? Yeah, any idea how to check these 5 consecutive 1s? How we can check? सांगू शकते कोण? 5 1s आहेत डेटामध्ये, हे चेक कसं करणार? हा ठीक आहे. आता इथे स्क्रीन बघा माझी, मी काय एंटर करते बघा, डेटा 1 1 1 1 1 1 1 1 हा माझा डेटा आहे. तर त्याच्यामध्ये 5 1 सलग आलेले आहेत, हे मला कसं कळणार?
5 1चा एक कॅरेक्टर सेट करून.
कॅरेक्टर, ओके. अजून सी इझिएस्ट वे काय हे करा माहिती का, व्हॉट यू कॅन डू. सो एक काउंटर घ्यायचं, त्याला 0ला असाइन करायचं फर्स्ट. ठीक आहे. जसा तुमच्या डेटामध्ये 1 फाइंड होईल, ओके, 1 एंटर होईल, तसा तो काउंटर 1 झाला पाहिजे, इन्क्रीज झाला पाहिजे. ठीक आहे. इफ आय फाइंड 1, देन काउंट +1, then next one count +2. Likewise, when the counter value becomes 5, it means that my data is having 5 consecutive 1s. So माझं next field will be 0. Simple logic वापरायचं. Okay, if count becomes 5, then it means that 5 consecutive ones आलेला आहे, so next field will be 0. That logic you have to use, or you can use any logic, but it is simple to take this, so that's why I told. Okay, so this way you can implement this one. And um, character stuffing is easy. The alias takes, it is very easy. You have to store this character in one array, or you can store it by separate values, also d of 0, d of 1. Likewise you can store and just display the message. याच्यामध्ये काय वेगळं करायचं नाही, just take the message and display, एवढंच करायचं. Only thing is that in case of the bit stuffing. Okay, so you have to try these two programs, not try, you have to implement these two programs. So next lecture we will discuss this. So I'll ask anyone randomly. If you have any doubt, you can ask me anytime, I'll tell you. So that is for today. So we have seen only one task of the data link layer, so that is nothing but the framing, and which is more important over here. Okay, so let's stop. So any doubt? Anybody is having any doubt?
मॅम आता प्रोग्राम ग्रुप
No, ma'am. No.
No. आणि काय अजून कोणतं काय विचारत होतं?
हा प्रोग्राम ग्रुप वरती शेअर करा.
काय what I share? PPT or
program?
Okay, program I'll share. Okay, I'll share it. Okay, so we'll stop over here.